Hello everyone, myself Prabhas Singh. Today in this lecture we will discuss about the famous problem that is 01 knapsack. This problem will be solved by the dynamic programming approach. Now what exactly is a problem statement? We are given a knapsack with a capacity W. Knapsack with capacity capital W. There is a set S containing n items. Each item has a weight and value associated with it. Each item I has a weight and value associated with it. Now, how to pack a knapsack in such a way that the maximum value or profit can be attained? Again, going back to the problem statement, we are given a bag or a knapsack with a capacity capital W. We are given a set S containing n items. Each item has a weight Wi and Vi as a value. We have to pack a knapsack in such a way that the maximum profit or the maximum value can be attained. There are two types of knapsack, that is 01 and fractional. In fractional knapsack is basically a greedy approach. What we will do, we pick the item in the fractional part as well. But in 01 knapsack, we either pick the item, accept, or either we will reject the item. Now, step number 1, characterize the structure of optimal solution. During the structure, let there are n number of objects, the profit values are this, and the weights are this, the maximum capacity is M or W. So we are defining the structure in the first step. The problem will be broken down into two sub-problems here. How it can be broken down into the two sub-problems? When we have a capacity capital W, there is a weight of an item I. There can be a possibility that weight of an item is greater than the capacity. Or there can be a possibility that weight of an item is less than the capacity. When this is greater than the capacity, this item will not come into the bag. If this is less than the capacity, this item will come into the bag, and this we will see how we will proceed in the coming steps. During the recursive formulation, it has been defined that BI, W. I stands for item and this stands for the weight of an item. If I or J equal to 0, then it will be simply W. I or W equal to 0, then it will be simply 0. If the weight of an item is less than capacity of the knapsack, then it will be the previous value. If the capacity of the knapsack is greater than or equal to, what we are saying is if J greater than equal to weight of an item, that is capacity is greater than equal to weight of an item. So what we are saying is that we are either calculating a previous value or we are considering previous item minus the capacity of knapsack plus the value attained from them. And we will return a maximum value of that. Moving ahead, we will see the optimal solution for the 01 knapsack problem with the help of a recursive formulation. What the algorithm is, initially if we think about, there is a weight 0 to W. We simply update is as 0 as it is being about the first row. If we talk about this, it is about the first column. This is taking the reference of the previous sub-problem. We have standardized as this, the base solutions. If I equal to 1 to n, number of items, and the capacity is 0 to W, so what we are doing is if capacity is greater than Wi, so do if. Then if this wala part is greater than this, so what BIW is updated with this, else BIW is updated with this. What we are saying is capacity is greater than Wi. So what we are saying that Bi comma W once can be Bi minus 1 comma W, Bi minus 1 comma W coin as Wi plus Vi, or Bi minus 1 comma W. This means that we rejected it, the item. We rejected I. This means that accepted I. And this is a solution coming when we are saying that W less than Wi. That is, weight of an item is greater than knapsack. So what we are doing, we are not considering I. We are taking reference of I minus 1. That is simple as this. Now this is a question. What we will do in this is, if we talk about this position, this is item versus weight. If we talk about item versus weights, we will simply write item versus weight. So what we will do here is, if there is no item and no weight, it will be 0. No item, it will be 0, 0, 0, 0, 0, and it will be simply 0 using these two for loops, if we talk about. Right? Now, if we come at this position, we simply write this is 1. 1 means here the weight is, what we will do is, item is, this is item 1, this is item 2, this is item 3, this is item 4. Now, what we are seeing here is item 1 has a weight 2. So, what are the possibilities? If the item 1 has a weight 2, so what we are seeing here is the capacity is less than the item weight. If the capacity is less than the item weight, then what we are saying is Bi minus 1 comma W. That is, we simply return this value here. Now, here the capacity meets the item weight. So what we are saying that either the previous value, that is this, or Bi comma W must have Bi minus 1, W minus Wi plus Vi. If we talk about this position, it will be B1 comma 2 will be giving us B0. Now this is 2 minus 2, that is 0 again. Plus Vi is the value of this item, Vi3. So if we go through, this will be B0 comma 0 plus 3. Now what happened is, while calculating this value, we are taking the reference of this, or we initially go to this and simply add the value to this. That is 0 comma 0 plus 3, it will be 3, and we simply return as 3. Moving ahead, when we come here, we are taking a reference of this, and we move ahead by one pointer here. So what we will do is 0 plus 3 is 3, 0, then simply 3. If we come here, then it will be 0. This 0 plus 3 will be giving us 3. If we come here, then it will be 0, and this 0 plus 3 will be giving us 3. Hope this is clear as of now. Now, if we talk about the item number 2, item 2 has a weight 3. So what we are saying is, when it is 1 or 2, we will be taking previous values, that is 0 and 3. Once it is 3, so what we are saying is, we are, while calculating this, we are taking reference as this, right? And we go to this place, that is, what is this? If we are talking 2 comma 4, 2 comma 3, so what we are doing is, we have gone to 1 comma 0. Why 1 comma 0? This is I minus 1. This is W minus Wi. That is 1 comma 0 is this. And this is 0 plus that 4. That is, if this is 3 and that is 0 plus 4, so we simply write it as 4. Now, what is the meaning of this? This 3 is coming when we are not considering this item. And this 4 is coming when we have considered the second item, so it will be updated as 4. Similarly, when we come here, we will take a reference of this and we will simply see this 0 plus 4. So what is the meaning of this? We are taking item 1. If we have this value. If we add 0 plus 4, we are taking item 2. So it means it will be 4. Again, when we come here, is this position? We are taking a reference of this. Item 1 is to be taken. And if we come here, that is 3 plus 4, that will be 7. So what we will simply see is that 2 plus 3 is 5. At 5, we are getting is 3 plus 4 as 7. Similarly, if we talk about the item number third, it has a weight 4. So what we are saying is same, same, same. It will be 0, 3, 4. When we comes to this position, what we are saying is item 3. If we're taking the reference of this, item 3 is not included. If we're taking a reference of this plus 5, item 3 is in consideration, so it will be 5. Right? When we come here, we are taking a reference of this. This means that item 3 is not into the consideration and we are having a solution till item 2. And when we come this 0 plus 5, it is 5, then it will be a 7. So what we are saying that we are considering item 2 and 1, not at item 3 because it is returning 5 and item 2 and 1 is returning 7. If we talk about the weight 4, capacity 5. So what we are doing, same value, same value, same value. It will be 0, 3, 4 and same value as 5. At this location, what we are doing is previous value. And this plus 6 will be giving us 7 only. So we have got this as a solution. Now, how we will see that this can be printed out? Let's fill it again. Now, what we will see here is how it is to be printed. Because we totally focused on three things. Bi, comma W will be returning Bi minus 1, comma W if weight of an item is greater than the capacity. Else, what we are focusing is Bi, comma W will be giving us maximum value of what? Bi minus 1, comma W plus, comma Bi minus 1, comma W minus Wi plus Vi. Now, here we will see this item is returning 7. That is maximum profit. If we are having 7 here, Bi, comma W, and Bi minus 1, comma W is same, this and this. This means that this item is not taken into the consideration because while calculating this value, what we have done? We will pick this or we will have 0 plus 6 here. So we have returned this. Again, we go here and here. These two values are same. So we comes to a conclusion that item 3 is not being considered into the calculations or the solutions. If we come here, we are seeing that this is the item which we have picked. After returning this, what we will say, we will go to the position this. Why this position? Because here we are having 2 comma 5. 5 minus the weight of that item, that is 3. That is, we go to 2 minus 1 comma 2, that is 1 comma 2 position, that is here only. Item 2 is printed. Now, if we think about this and this, these two are not same. It means I is printed. And where we will go, this is 1 comma 2 position. So 1 comma 2 means 1 minus 1 comma 2 minus the weight of that item. It will be 0 comma 0, and we reach to an initial stage of this. Through this, we are saying that item 1 and 2 is printed. So we return solution as 1 comma 1 comma 0 comma 0. This is a solution which we have returned. Thank you.